Dear student, today we are going to discuss the derivative of vector with respect to its different parameter. For example, you have learned some vector and how you can differentiate with respect to its parameter. Before that, the basic important thing is that what is derivative? So derivative is nothing but it is the rate of change of some parameter with respect to some another parameter. That is what called as a derivative. Here r bar is equal to f of t. So r bar is the position vector. So for only one value of t, there is only one value of r. So r bar is equal to r bar plus delta r is equal to f of t plus delta t. So here, so delta r bar is equal to f of t plus delta t minus r bar. Just I resolve this part or I simplify this part, so I will get this equation. And if I divide by t, that means I have to observe the change of vector r bar with respect to vector t. So that is like delta r upon a delta t. So that will be f of t plus delta t minus f of t upon a delta t. So the limit of incrementary ratio at delta t tends to 0 is called as a derivative of f of t and is denoted by f of r or df of t upon a delta t. So df of t upon a delta t, this is equal to limit delta t tends to 0, f of t plus delta t minus f of t upon a delta t. So here this dr upon a dt is equal to limit delta t tends to 0. That means when time changes to 0, then what will be the dr upon dt? So definition of this is the position vector. So v bar is called as velocity. So velocity is nothing but rate of change of displacement. So that is nothing but velocity. And here acceleration is nothing but it is the rate of change of velocity is called as an acceleration. So here delta t tends to 0. That is also called as instantaneous velocity. That what do you mean by instantaneous velocity? Velocity of a certain particle at an instant. Similarly, what do you mean by the instantaneous acceleration? So instantaneous acceleration is nothing but the acceleration of certain moment of a particle at that instant. So that is what called as instantaneous acceleration. Basically, what is the purpose to learn this derivative? Because your velocity is nothing but the derivative of displacement. We can say that. Similarly, what do you mean by acceleration? So acceleration is nothing but the rate of change of velocity. So we will get the acceleration. So these are regarding the acceleration and velocity. Now we are going to solve some numerical. How we can calculate the magnitude of a given vector, how we can calculate the unit vector along the direction of a given vector. So such kind of numerical we are going to solve in present chapter. So first numerical we will take, for example, vector a bar, that is equal to 3 I cap minus j cap plus 2k cap. And you have asked the question, find out the magnitude of this vector. So as per our previous discussion, so vector a bar is nothing but in bracket ax square plus ay square plus az square. So this is a. Now just we have to substitute this value. My ax will be 3, my ay will be -1 and my az will be 2. Just we have to substitute this value in this equation. So what I will get? I will get 3 square plus -1 square, that is nothing but 1, plus 2 square. So like this. So this is nothing but 9 plus 1 plus 4. So 9 plus 1 10 plus 4, that is 14. So this is the magnitude of a given vector A, that is square root 14. Now I have to calculate the unit vector along the direction of the vector. So unit vector along the direction of this vector is 3i cap minus j cap plus 2k cap. So here unit vector I will call, suppose some vector a, that is nothing but some vector I cap. So that is a bar upon a magnitude of a. So my a bar is 3i cap minus j cap plus 2k cap. So that is nothing but mod A, that is root 14. So finally this unit vector along the direction of I cap 3 I cap upon 14 minus j cap upon 14 plus 2 k cap upon a 14. So this is the unit vector along the direction of a vector A bar. So similar numerical we are going to solve in our next lecture. So we will stop here.